What if one of the most successful families of predatory dinosaurs in Earth's history had never disappeared? When most people think of giant carnivorous dinosaurs, one name immediately comes to mind: Tyrannosaurus rex. For generations, it has been portrayed as the ultimate predator of the prehistoric world, the undisputed king of the dinosaurs. But long before Tyrannosaurus rose to prominence, another family of predators had already spread across much of the planet. They hunted in environments separated by oceans. They evolved on different continents. For tens of millions of years, they occupied the highest position in some of the most extraordinary ecosystems the world has ever seen. These were the Carcharodontosaurids. Their name means shark-toothed lizards, a reference to their long blade-like teeth. Yet despite the intimidating name, the Carcharodontosaurids were not a single species. They were an entire family of large predatory dinosaurs united by a common ancestry and a remarkably successful evolutionary design. To understand just how successful they became, we need to step back more than 100 million years. The world looked very different then. The continents were still drifting toward their modern positions. Sea levels were significantly higher. Vast coastal plains stretched across regions that are now deserts and mountains. Warm temperatures reached far into areas that today experience cold winters. It was a world filled with giants. Enormous plant-eating dinosaurs moved across floodplains and forests. And wherever these giant herbivores flourished, giant predators often followed. What makes the Carcharodontosaurids remarkable is not simply their size, it is their reach. If we could place a map of the mid-Cretaceous world in front of us and mark every major region where these predators appeared, a striking pattern would emerge. They were everywhere. In North America, one of their most famous representatives was Acrocanthosaurus. Living roughly 113 to 100 million years ago, Acrocanthosaurus reached lengths of around 36 to 39 feet. Fossils discovered across the southern United States reveal an apex predator perfectly adapted to dominate its environment. Its most distinctive feature was a series of elongated vertebral spines that formed a ridge along its back. Yet its significance goes far beyond appearance. Acrocanthosaurus demonstrates that long before giant tyrannosaurs came to dominate North America, members of the Carcharodontosaurid lineage were already occupying the role of top predator. Thousands of miles away, another branch of the family was evolving into even larger forms. In South America, the landscape was home to Giganotosaurus. Today, Giganotosaurus is often introduced as a rival to Tyrannosaurus rex in discussions of size. But during its own time, it was not competing with Tyrannosaurus at all. The two animals lived millions of years apart and on different continents. Giganotosaurus inhabited a world populated by gigantic titanosaurs, including some of the largest land animals known to science. To survive in such an environment required a predator capable of confronting prey on an immense scale. With a length approaching 13 meters, Giganotosaurus became one of the largest terrestrial carnivores ever discovered. And it was not alone. The same region later supported another giant Carcharodontosaurid known as Mapusaurus. Multiple Mapusaurus individuals have been found together in Argentina, creating one of the more intriguing discoveries associated with large predatory dinosaurs. While scientists continue to debate exactly what the evidence means, the fossils have raised questions about whether these animals may have displayed some degree of social behavior. The answers remain uncertain. Meanwhile, across the Atlantic Ocean, another giant member of the family ruled the river systems and coastal plains of northern Africa, Carcharodontosaurus itself. This enormous predator lived in one of the strangest ecosystems ever reconstructed from the fossil record. Its environment included giant fish, massive crocodile relatives, and a remarkable diversity of large dinosaurs. In a landscape already crowded with oversized animals, Carcharodontosaurus still managed to establish itself among the dominant predators. Its skull exceeded 5 feet in length, and its serrated teeth were built for slicing through flesh rather than crushing bone. Taken individually, each of these animals is impressive. Together, they reveal something far more important. The Carcharodontosaurids were not an isolated success story. They were a global dynasty. Across North America, South America, Africa, and other regions, members of this family repeatedly evolved into apex predators. Different species occupied different habitats, yet they shared a common evolutionary blueprint that proved extraordinarily effective. For millions of years, that blueprint worked. Generation after generation, Carcharodontosaurids stood at the top of food webs that supported some of the largest creatures ever to walk the earth. And all of this happened before Tyrannosaurus rex became the icon we recognize today. In many ways, the story of giant predatory dinosaurs did not begin with Tyrannosaurus. It began with another dynasty, one that spread across continents, shaped ecosystems, and seemed destined to last. Yet by the late Cretaceous, something was changing. The rulers of one age were disappearing. The mystery is not how they came to dominate the world, but why they vanished. And more importantly, what if they never had? Why did evolution keep producing giant Carcharodontosaurids? At first glance, the answer might seem obvious. Large predators became large because being large offered advantages. But in nature, things are rarely that simple. Size comes at a cost. A larger animal requires more food. It grows more slowly. It needs more territory. And if resources become scarce, giant animals are often among the first to suffer. From an evolutionary perspective, becoming enormous is a risky strategy. So why did it happen again and again within the Carcharodontosaurid family? The answer may have had less to do with the predators themselves than with the world around them. To understand these hunters, we must first understand their prey. Throughout much of the Cretaceous period, many terrestrial ecosystems were dominated by titanosaurs. These long-necked herbivorous dinosaurs were among the largest animals ever to walk on land. Some species reached lengths exceeding 98 feet. Others may have weighed more than 110,000 or even 132,000 pounds. Even by dinosaur standards, they were extraordinary. Imagine standing in a floodplain 100 million years ago. In the distance, a herd of titanosaurs moves slowly across the landscape. Each animal towers above the surrounding vegetation. Their necks extend upward like moving cranes. Their footsteps leave impressions large enough to collect rainwater. For smaller predators, such creatures would have represented an impossible challenge. For Carcharodontosaurids, they represented opportunity. This was unlikely to be a coincidence. Predators do not evolve independently. Their history is closely tied to the animals they hunt. As herbivores became larger, the ecological opportunities available to large predators increased as well. A landscape filled with giant animals contains an enormous amount of biological energy. Under such conditions, natural selection can favor larger hunters capable of interacting with these immense prey populations. Over millions of years, this relationship may have created an evolutionary feedback loop. Yet size alone was not enough. What made these animals successful was their ability to function within some of the most productive ecosystems of the Cretaceous world. Many of the regions they inhabited were warm, biologically rich environments, shaped by extensive river systems, coastal plains, and seasonal floodplains. Vegetation flourished, herbivore populations expanded, and apex predators benefited from the abundance below them. In a sense, the giant Carcharodontosaurids were not simply products of evolution. They were products of entire ecosystems. Their existence reflected the immense productivity of the worlds they inhabited. This helps explain an important pattern in Earth's history. Giant predators do not appear because evolution is attempting to create monsters. They appear because ecosystems can support them. When food webs become large enough, stable enough, and productive enough, natural selection sometimes opens the door to giants. The Carcharodontosaurids walked through that door more successfully than almost any predatory dinosaurs before them. By the middle of the Cretaceous, they had become dominant hunters across multiple continents. They were not isolated giants. They were the apex representatives of a much larger ecological system. From North America to Africa to South America, giant predators remained at the top of the food chain, which makes what happened next even more surprising. By this point in their history, the Carcharodontosaurids had become some of the largest predators the world had ever seen. Yet size alone does not explain their success. To understand why these animals dominated so many ecosystems, we need to look beyond measurements and examine something far more important: how they hunted. This is where the story becomes particularly interesting, because despite frequent comparisons in popular media, Carcharodontosaurids and tyrannosaurs were not simply different versions of the same predator. They represented two very different evolutionary solutions to the challenge of bringing down enormous prey. Tyrannosaurs, which would later dominate parts of the late Cretaceous, possessed exceptionally robust skulls and some of the most powerful bite forces ever measured for a terrestrial animal. Their jaws were built to withstand tremendous stress. Rather than simply cutting flesh, they could crush bone itself. A tyrannosaur bite was designed to overwhelm, to grip, to break, to inflict catastrophic damage in a single encounter. Carcharodontosaurids appear to have followed a different path. Their skulls were generally longer and less heavily built than those of giant tyrannosaurs. Their teeth were narrower blade-like and finely serrated. Instead of functioning like crushing spikes, they worked more like rows of biological knives. Rather than relying primarily on bone-crushing power, these predators may have specialized in delivering deep slicing wounds. Imagine two successful predators in today's world: a lion and a great white shark. Both are apex hunters. Both can kill large prey, yet they do so in very different ways. The lion often relies on strength control and close physical engagement. The great white shark frequently inflicts massive wounds through cutting bites, allowing blood loss and trauma to weaken its victim. The comparison is not perfect, but it helps illustrate an important idea. Evolution does not produce a single best predator. It produces different strategies for different ecological circumstances. The giant Carcharodontosaurids may have excelled in ecosystems filled with titanosaurs and other massive herbivores, where long, slashing bites could wound prey far larger than themselves. For millions of years, that strategy worked remarkably well. When we look at Tyrannosaurus, it is tempting to view it as the final and ultimate version of a giant predatory dinosaur. But the fossil record suggests something different. Long before tyrannosaurs reached their peak, the Carcharodontosaurids dynasty had already discovered its own path to dominance. Not by crushing, but by cutting. Not by following the same blueprint, but by proving there was more than one path to dominance. And for tens of millions of years, it worked. For a dynasty that had dominated ecosystems across multiple continents, the ending is surprisingly difficult to explain. In fact, one of the most overlooked facts about the Carcharodontosaurids is that they did not disappear during the asteroid impact that ended the age of dinosaurs. They were already gone. Most of the giant Carcharodontosaurids vanished roughly 90 million years ago, tens of millions of years before the Chicxulub asteroid struck Earth 66 million years ago. That detail changes the story completely, because it means their decline cannot simply be explained by a single catastrophic event. Instead, paleontologists are left with a more challenging question.
Why did one of the most successful groups of predators in dinosaur history begin to disappear while the age of dinosaurs was still continuing?
The answer remains uncertain, but the fossil record provides several clues. One possibility involves changing ecosystems. The mid-Cretaceous world was not static. Continents continued to drift apart, climates shifted, and habitats that had supported giant predators for millions of years gradually changed. Even subtle environmental changes can ripple through an ecosystem, affecting prey populations, migration patterns, and food availability. Another possibility involves sea levels. During parts of the late Cretaceous, global sea levels remained exceptionally high, reshaping coastlines and altering vast stretches of habitat. entire ecosystems were fragmented or transformed. For large predators that depended on stable populations of massive herbivores, such changes may have created new challenges. Then there are the titanosaurs themselves. For millions of years, giant herbivorous dinosaurs had been a defining feature of many Carcharodontosaurid ecosystems. But herbivore communities were changing. Different species appeared, others declined, and ecological relationships that had existed for millions of years may have been disrupted. A predator's future is often tied to the fate of its prey. And there is another intriguing possibility: competition. As the Carcharodontosaurids declined, other predatory groups began expanding into ecological roles that had once been dominated by giant shark-toothed hunters. In some regions, large tyrannosauroids were evolving into increasingly formidable predators. Elsewhere, different theropod lineages continued adapting to changing environments. This does not mean tyrannosaurs directly drove Carcharodontosaurids to extinction. The evidence does not support such a simple conclusion. But evolution rarely leaves empty spaces for long. As one dynasty weakened, others were ready to expand. This was not a sudden extinction. It was a slow disappearance recorded only in scattered fossils, shifting ecosystems and evolutionary changes that unfolded over millions of years. The Carcharodontosaurids had conquered much of the world, yet even they were not immune to change. But did their decline have to happen, or could history have unfolded differently? So far, we have followed the evidence. We have explored the rise of the Carcharodontosaurids, the ecosystems that supported them, and the mystery surrounding their disappearance. Now we arrive at the question that inspired this entire story. What if their decline never happened? To answer that question, we do not need to leap forward to the modern world. Instead, we return to the late Cretaceous, where the future of these predators may have been decided. Imagine that some Carcharodontosaurid populations successfully adapted to the environmental changes that challenged their relatives around 90 million years ago. The ecosystems continued to change. The continents continued to drift, but the dynasty survived. At first, the difference might have seemed small, a few surviving populations scattered across ancient landscapes. Yet over millions of years, even small changes can reshape the course of evolution. And at precisely this moment, another group of predators was beginning its rise: the tyrannosaurs. When we think of tyrannosaurs today, we often imagine giant apex predators. But for much of their evolutionary history, they were relatively modest animals. Their rise to dominance occurred later, after many giant Carcharodontosaurids had already disappeared. That timing may not be a coincidence. Large predators require enormous territories and vast amounts of prey. Most ecosystems can support only a limited number of apex hunters. If giant Carcharodontosaurids had remained widespread, they may have continued occupying ecological roles that tyrannosaurs later inherited. This does not mean tyrannosaurs would have vanished. Far from it. They may still have evolved into formidable predators. But perhaps they would have remained secondary players in ecosystems already dominated by giant, shark-toothed hunters. In this alternate world, the late Cretaceous could have looked very different. Instead of a landscape increasingly shaped by tyrannosaurs, parts of the world might still have been ruled by descendants of the ancient Carcharodontosaurid dynasty. The structure of entire ecosystems could have shifted. Competition would have intensified. Evolutionary pressures would have changed. And every change would influence the next generation. The world we know today emerged from countless evolutionary crossroads, and the disappearance of the Carcharodontosaurids may have been one of them. If they had survived, the age of tyrannosaurs might never have unfolded in quite the same way. And that raises an even larger question. If the Carcharodontosaurids had endured long enough to witness the final days of the Cretaceous, what would have happened when the asteroid finally arrived? When people imagine an alternate history for the Carcharodontosaurids, the first question is often simple. What if they survived to the present day? But from a scientific perspective, there may be a more interesting question. Would Tyrannosaurus ever have become the apex predator we know? The rise of Tyrannosaurus was not inevitable. Evolution does not follow a predetermined path. Every lineage evolves within the opportunities created by its environment, and sometimes those opportunities appear only when another group disappeared. By the late Cretaceous, giant Carcharodontosaurids had largely vanished from the ecosystems they once dominated. Over time, new predators expanded into ecological roles that had become available. Among them were the tyrannosaurs. Over millions of years, certain tyrannosaur lineages evolved larger bodies, more powerful skulls, and the immense bite forces that would eventually make Tyrannosaurus rex one of the most formidable terrestrial predators in Earth's history. But what if giant Carcharodontosaurids had never disappeared? Imagine a late Cretaceous world where descendants of Carcharodontosaurus, Giganotosaurus, or their relatives still occupied the top levels of the food chain. In such ecosystems, resources would already be claimed by established apex predators. Competition for prey territory and ecological influence would be intense. Under those conditions, tyrannosaurs might still evolve successfully, but perhaps they never become giants. Perhaps they remain medium-sized predators adapted to different prey and different ecological roles, while the descendants of the shark-toothed dynasty continue dominating the largest hunting niches. The result would be a very different final chapter of dinosaur history. Not because tyrannosaurs disappear, but because they never become the rulers of their world. Of course, we cannot know whether this is exactly what would have happened. The fossil record cannot provide a definitive answer. Yet the possibility reveals something important about evolution. History is shaped not only by survival, but by opportunity. The disappearance of the Carcharodontosaurids may have altered the course of dinosaur evolution long before the asteroid struck Earth. And perhaps that is the most fascinating conclusion of all. The age of Tyrannosaurus may not have begun because tyrannosaurs were destined to rule. It may have begun because another dynasty faded first.